Imagine you're standing in the middle of nowhere. No signs, no landmarks. Completely lost. Yet within seconds, your phone knows exactly where you are. There are no road signs, no one around to ask. Sometimes, not even an internet connection. Yet somehow, your phone still knows exactly where you are. So how is that even possible? The answer isn't hidden inside your phone. It's hundreds of kilometers above your head, high above Earth. A silent network is working every second, making modern navigation possible. This is the Global Positioning System, or GPS. It's not just one satellite, it's an entire constellation of satellites orbiting high above Earth. Together, they make sure that wherever you are on the planet, several satellites are always within reach. Let's zoom in on one of these GPS satellites. At first glance, it looks like any other spacecraft, but this satellite isn't taking photos or watching where you go. It has one incredibly important job. Every GPS satellite continuously broadcasts one simple thing: the exact time the signal leaves the satellite. Not every second, not every millisecond, but with astonishing precision, accurate to within billionths of a second. That tiny timestamp is the secret behind GPS. That signal doesn't travel to just one phone. Every second, it spreads across the entire planet. Millions of smartphones, cars, airplanes, ships, emergency vehicles, and countless other GPS-enabled devices are all quietly listening to these satellites at the very same time. Now, imagine you're standing here with your phone. At this very moment, it's listening to several GPS satellites at the same time. Each one is sending the exact moment its signal left the satellite, and your phone receives every one of those signals in fractions of a second. Although every satellite sends its signal at nearly the same time, they don't all reach your phone together. Some signals arrive just a tiny fraction of a second before the others. Your phone carefully compares these incredibly small differences in arrival time from every satellite. Radio signals travel at the speed of light, almost 300,000 kilometers every second. Because your phone knows exactly when each signal was sent and when it arrived, it can calculate how far away each satellite is. Now your phone knows exactly how far away one satellite is, but that's still not enough to pinpoint your location. Now let's add a second satellite. Your phone measures its distance too. Each satellite creates its own invisible sphere of possible locations. With 3 measured distances, the possible locations shrink even further. Instead of an entire circle, only 2 possible points remain. Finally, a 4th satellite provides the last missing piece of the puzzle. With 4 precise distance measurements, your phone can eliminate the incorrect location and identify one exact position. In just a fraction of a second, your phone knows exactly where you are. After comparing signals and calculating the distance to each satellite, your phone has everything it needs to determine your exact position. That position is then displayed on your map as the familiar blue location marker, updating every second as you move. Every time you open a map, all of this happens in just a fraction of a second. So, if GPS is so accurate, why does your location sometimes drift or jump? The answer is simple. GPS signals have to travel nearly 20,000 kilometers through space before reaching your phone. Along the way, buildings, trees, mountains, and even parts of the atmosphere can weaken or delay those signals, making your location slightly less accurate. In open areas, GPS signals usually travel straight from the satellites to your phone. But in busy cities, tall buildings can get in the way. Some signals are blocked completely, while others bounce off glass and concrete. Because that reflected signal travels a longer route, your phone thinks the satellite is farther away than it really is. and your location can shift by several meters. Your phone assumes every GPS signal traveled in a straight line, but when a signal bounces off a building, it has to travel a longer route before reaching your phone. Because the journey took longer, your phone believes the satellite is farther away than it actually is. That tiny timing difference is enough to calculate the wrong position, causing your blue dot to drift. But your phone doesn't rely on just one group of satellites. Most modern smartphones can receive signals from several global navigation systems, including GPS, Galileo, GLONASS, and Beidou, all at the same time. With more satellites to choose from, your phone can compare more signals, ignore unreliable ones, and calculate your location much more accurately. That's why your blue dot quickly becomes steady again, even in places where some signals are blocked or reflected. Whether you're exploring a quiet lakeside town, hiking through the mountains, or discovering a city you've never visited before, your phone is constantly working behind the scenes to guide you. In just a fraction of a second, it receives signals from satellites thousands of kilometers above Earth, compares millions of tiny timing measurements, and calculates your position with remarkable precision. It's a technology so reliable that most of us use it every day, without even thinking about the incredible science making it all possible. Every time you unlock your phone and check your location, an extraordinary journey unfolds above your head. Signals travel thousands of kilometers through space, racing at the speed of light from satellites orbiting Earth, all to answer one simple question: where are you? It's one of humanity's greatest engineering achievements, working silently, every second of every day. Until next time, stay curious.